Good evening, everyone. So last class we discussed regarding continental drift and seafloor spreading. So, continental drift theory was proposed by Alfred Wegener in 1912 in order to explain the differences in climatic conditions experienced across the world in the same place across the time. And he proposes a theory to justify this observation. That theory is what is called as continental drift theory. The continental drift theory basically says that during the Carboniferous period there was a single supercontinent which he called as Pangaea, and single super ocean called as Panthalassa. Okay, so and this single continent started to get separated, started to rift apart, and a huge rift developed between east to west. That created a Tethys Sea in between, and the northern part was called as Angara land or Laurasia. The southern part was called as Gondwana land. The northern part consisted of North America, Greenland, Eurasia without Arabia and India. Southern part included South America, Africa with Arabia, then Madagascar, India, Antarctica and Australia. So gradually a north-south rift also would develop that would separate North America including Greenland from Eurasia, South America from Africa. A Y-shaped rift would separate India, and India starts to move towards Eurasia and it collides with Eurasia and becomes part of it. Australia would get separated and starts to move towards the east. Africa would get separated from the rest of these and move towards the north, and finally the Arabia would get separated from Africa. Okay, here North America and South America will get connected. Okay. So this is the present position of the continents. This is what is called as continental drift. The reason suggested by Alfred Wegener was two types of forces, one force acting north to south, another east to west. This force, which he called it as the pole fleeing force, acts in north-south direction. It is the result of gravitational differential force and force of buoyancy, which are trying to adjust the center of gravity and center of buoyancy. Okay, so and the tidal forces are the one which are responsible for east-west movement, and that is due to gravitational force of sun and moon. Okay. Evidences suggested by Alfred Wegener to justify the theory of continental drift includes: first one, jigsaw fit of continent, that is similarity of coastlines across the world. Then second one, structural evidences, that is similarities of mountains and the physical features across the world. And then stratigraphic evidences, that is the layers of rocks having exact similarities, separated even though separated by wide oceans. And fourth, fossil evidences across the world. So for example, Mesosaurus, a freshwater reptile, and then Glossopteris, a fossil fern of subpolar region. Their distribution pattern can be explained with the help of continental drift. And then comes placer deposits, glacial deposits, placer deposits, their distribution patterns and their overall movement. Okay, so that can be explained here, and as well as the glacial tillites deposits. Okay, so all of this can be explained using this. The criticism includes the forces suggested by Alfred Wegener being very weak to cause the movement of continents, and the free movement of the continents over the oceanic floor without offering any resistance, and why this division happened only in the time of Carboniferous period. Okay, all of this would explain. All of this could not be explained by Alfred Wegener, so that becomes the most important criticism. Seafloor spreading theory basically talks about the presence of mid-oceanic ridges on the oceanic floor, okay, which is a theory proposed by Harry Hess in 1961. And as per this theory, the entire mid-oceanic ridge is basically a crack in the oceanic floor which allows the magma from the bottom, from the lower part, to rise up all along the entire ridge. This rising magma accumulates on both the sides, and it solidifies. As it solidifies, it pushes the older parts apart. As the older parts gets pushed apart, the new oceanic floor gets continuously created here. Okay, so this creation of new oceanic floor would continuously push the older ones away from the mid-oceanic ridge. It's because of this, there's exact similarity of the properties of rocks away from the mid-oceanic ridges. Okay, and the age of the rocks increases away from the ridges, and oceanic crust is thinner, continental crust के comparison से, and oceanic crust is very very younger. Okay, so and we don't have any other older crust. It's mainly because as the oceanic crust gets pushed in some parts where they converge or collide, so there is a part of the oceanic crust which undergoes subduction. Okay, so I'll tell you in detail what exactly is this process and all, and it gets destroyed basically. It gets created on one side, it gets destroyed on the other side. So it is because of this the oceanic floor continuously moves, it continuously spreads. This is what is called as sea floor spreading. Sea floor spreading. Okay, this is the idea given by Harry Hess. Okay. So we in the beginning we also discussed briefly about isostasy, if you remember. Okay, isostasy is a concept which is required in plate tectonics also. Okay, isostasy is basically the floating mechanism of the crust over the lower denser mantle, and crust being lower in density, it experiences the buoyancy force, and if there is any change in the nature of the crust, change in the thickness or change in the density, so that will adjust accordingly. It rises or it subsides. Okay, so that kind of adjustment is what is called as isostasy. बताइए कुछ doubts है? What did Alfred Wegener say? What is the force given by him? So where did he talk about interior heat? है ना? वो तो आपको बाद में समझ आएगा जब प्लेट टेक्टोनिक्स पढ़ोगे. ठीक है? So the forces which he suggested, that cannot cause the movement. That is the point here. है ना? The forces suggested by him is not the reason actually. वो तो अंदर का है. है ना? So the reason behind the continental drift is actually the plate movement. Plate movements are driven by the endogenetic movements. Okay, so we'll talk about that. ठीक है? So और बताइए. Anything else? So sea floor spreading के बारे में लिखना है ना? ठीक है. So write about this. Mapping of oceanic floor. Mapping of oceanic floor revealed the following information. Revealed the following information. Okay, point wise. Presence of mid-oceanic ridges. Presence of mid-oceanic ridges along the oceanic floor. Next. These ridges are active. These ridges are active, resulting in continuous volcanic eruptions. Resulting in continuous volcanic eruptions. Next. Rocks on either side of the ridge are of same age with similar composition with similar composition and magnetic properties. Next, the age of rocks along the oceanic floor. Age of rocks along the oceanic floor. Increases away from the ridge. Increases away from the ridge. Next, rocks of oceanic crust. Rocks of oceanic crust are younger than the continental crust. Younger than the continental crust. Next, oceanic crust is thinner than the continental crust. Oceanic crust is thinner than the continental crust. Next paragraph. Based on the above observations, Harry Hess in 1961 proposed the theory of seafloor spreading. The theory of seafloor spreading. According to this theory, constant magma eruptions along the oceanic floor near to ridges causes the rupture of oceanic crust, causes the rupture is cracking, causes the rupture of oceanic crust. Full stop. The new lava wedges onto, the new lava wedges, wedges, wedges onto the oceanic crust and this pushes the oceanic crust on either side. This pushes the oceanic crust on either side. Therefore, the oceanic floor spreads. Therefore, the oceanic floor spreads. Next point. The spreading crust sinks down. The spreading crust sinks down at the oceanic trenches. And gets consumed. And gets consumed. ये है sea floor spreading.
Core samples and sonar readings from around the mid-Atlantic ridge, Hess made an astonishing discovery, a phenomenon almost beyond comprehension. The age of the Atlantic. Analyzing core samples and sonar readings from around the mid-Atlantic ridge, Hess made an astonishing discovery, a phenomenon almost beyond comprehension. The age of the Atlantic Ocean floor, he determined, was progressively older the further it moved away from the ridge.
This is roughly like we can imagine there's a huge crack here. Okay, this is the Atlantic Ocean, that is Europe, this is North America, and it is equally spreading on both the sides.
Hess had discovered that the seafloor was spreading. He concluded that molten rock was being forced up from inside the Earth at the ridge, where it then formed into new crust on the ocean floor. Gradually, it was pushed away on either side as more molten rock continued pushing up from behind it. Hess called his great discovery seafloor spreading.
Harry Hess was in a position that he could bring it all together. Things were spreading apart and new Earth was being generated. But if you did this for long enough, the Earth should grow. And it doesn't.
The Earth doesn't get any bigger.
No. Harry appreciated the fact that if new Earth was being generated in one area, they have to be consumed or recycled in another area.
The process that recycles the crust of the spreading ocean floor back inside the Earth is called subduction.
This is somewhat like this. This is the mid-oceanic ridge where the magma is rising, and that is accumulating on both the sides, and it solidifies, and the older one gets pushed away from the ridge. Fine. That is called as seafloor spreading. So next, plate tectonics theory. What do you mean by tectonic? To build. Tectonic means to build. So what are plates? Part of lithosphere. A fragment of lithosphere, like a single piece of lithosphere. So let's start with the basic idea of plate. So what is plate? We know the lithosphere. Lithosphere is like an outer shell around the earth. Very, very thin. For representation purpose, we make it proportionally a little bit thicker. It is never this thick. It's a very, very thin shell. Okay, this shell extends up to the depth of 100 kilometers, and it is made up of upper part of crust and upper mantle. Okay, upper part of upper mantle and crust together forms this hard and rigid shell. Now each of this, the entire lithosphere is divided into individual parts, individual segments, like this. Each individual segment is what is called as a plate. This is what is one plate. Okay? And plate we always see on a world map which is almost flat all the time. So people imagine this to be flat. It is not flat. You have to imagine as a part of a sphere. Obviously, it is curved. Okay, it's like a part of a sphere, one particular part. It is not completely flat. Fine. So, like this, the entire Earth's lithosphere is divided into different fragments. बहुत सारा ऐसे fragments है. And interestingly, they are never the same. Okay, so what we right now have, the plates, their numbers was different earlier. It will be different future. वो कैसे है तो वो देखते हैं, समझ आएगा. Okay, so right now we have a total of 7 major plates. Major plate is the one which is very big in size. Big sized ones, they are called as major plates. Minor plates, there are many, 30, 35, 40. Some of them say that is around 30, 33, 32. Okay, there are many small plates are there. So all of these plates together forms the outer shell of the Earth. That is what is called as lithosphere. So what is the thickness of lithosphere? 100 kilometers. So therefore the thickness of a plate is also 100 kilometers. Fine. In this, the upper part is actually very less. If you see in 100 kilometers, the upper part is, the crust is very less. The major part is the upper part of upper mantle only. Okay, so it doesn't matter which type of crust is there in the upper part. Fine. So if this is what we are representing, in some cases there's a oceanic crust, in some cases there may be continental crust also. So this is the part of the plate where there is oceanic crust, this is the part of the plate where there is continental crust. It doesn't matter which type of crust. It's about having a single unit. On the same plate, one side there may be oceanic crust, another side there may be continental crust, doesn't matter. Where exactly there is a discontinuity between the two different parts, two different plates. So that is what is plate boundary. Fine. Plates are not defined based on the crust. It is the fragment of the entire lithosphere. Fine. So there is nothing called as oceanic plate, continental plate. There is only margins. This is one plate. Okay, if there is oceanic crust on one side, this is oceanic margin of the plate. The side of the plate where there is oceanic crust. This is the same part of the plate where there is continental margin. This is the continental margin, this is the oceanic margin. As such, there is no oceanic plate and continental plate. Generally, we use this term oceanic plate, continental plate. It's basically referring to the oceanic margin or continental margin. Because there is no plate which is completely continental. Okay, there is no plate which is completely continental. There is only one plate which is completely oceanic, that is Pacific plate. Otherwise, most of the plates contain some parts of oceanic crust, some parts of continental crust. It's all mixed up together. You can very clearly see from the satellite imagery itself the presence of plates and their boundaries. Okay, this is the representation version. If you take the satellite imagery, you can very clearly see. Okay, so first let me show the satellite imagery itself. Okay, this is the satellite imagery, right? Okay, so come to this part. There's a huge plate here. If you can identify the plate boundary, let's see. So this is the mid-Atlantic ridge. That is actually the boundary. Okay, can you see? This boundary ends here, and then there is another crack here, if you can notice, very clearly visible. And then it goes still here. Can you see this deep part? Okay, that is the deeper part, that is color coded. Deeper blue means depth, higher depth. Okay, the plate boundary goes like this, and it comes somewhere like this. This is one plate. This is South American plate. Fine. You can identify like this all the other plates. Here is North American plate. African plate is much more clearly visible. Okay, can you see the crack here? This is the same Atlantic ridge. The crack goes still here, here, okay, and it comes here. It goes like this. It comes and joins somewhere like this. It joins somewhere like this. There's a huge plate, African plate. There's one side oceanic crust, this side oceanic crust, in between there's continental crust. It is the Pacific plate is the only plate which is completely oceanic in nature. You cannot see it in a single picture like this. Okay, so here you can see. This is the South American plate which we just marked, right? Okay, so see, this is the Pacific plate. You can very clearly see the boundary. This is Pacific plate, only this part. Pacific plate is different from the Pacific Ocean. A part of Pacific Ocean has Pacific plate. There is some part of the Pacific Ocean where there is another plate. This is a smaller plate. This is the Pacific plate. The only major plate with no continental crust is completely oceanic crust. There is nothing significant whether there is continental crust or oceanic crust. It is just accident. This is North American plate. Okay, it starts from here, goes till here. Okay, so and gets covered like this. This is North American plate. Of course, on a flat map, it will see it straight. But if it is circular, you will understand this. This is North American plate. So this is South American plate. Okay, this is number 1 Pacific, number 2 North American, number 3 South American, number 4 African, number 5 is Eurasian. Okay, can you see? It starts from here, it goes like this here, from here, comes still here. This entire Indonesia part, Southeast Asian part comes under this only. This is all Eurasian plate, number 5. Number 6 is interesting, you can see. On one side there is continental, this entire part, India's part continental, and then there is ocean. On another side again there is continental. Can you see this part? This is the continental part. This is continental, this is continental. India and Australia belongs to the same plate. Indo-Australian plate. Number 7 is hidden here, entire plate around Antarctica. It is the entire part. Okay, if you see the spherical, the 3-dimensional, you will see the actual plate. This is Antarctican plate number 7. Total of 7 major plates. So what are they? Number 1, Pacific plate. Number 2, South American. Number 3, North American. Number 4, African. Number 5, Eurasian. Number 6, Indo-Australian. Number 7, Antarctica. These are the major plates. So let me show minor plates. There are a few minor plates. Nazca is a minor plate. NAZCA, Nazca. It is located between Pacific and South American plate. Towards the north of Nazca, between Nazca, South American, North American and Pacific, there is a small plate here. Okay, this is what is called as Cocos plate. There is a Caribbean plate here. Can you see? Then Arabian plate is a separate plate, Arabian Peninsula. Towards the north of Arabian plate, there is Turkish plate. Okay, Turkey, Anatolia. Then there is Philippines plate. Okay, so many small plates are there. Fiji plate, Solomon plate. They're all in between pieces, small pieces. So the earth is made up of many such plates together, particularly the lithosphere. Lithosphere is made up of such many plates. All of these plates merged together forms the lithosphere, the outer shell of the earth. This is the idea of plate. Okay, so you can draw the figure of plate somewhat like this. Okay, usko chodo. This is maybe one plate. So together it will be called as one plate if there is no continuity between the two parts. There is proper discontinuity all along the length of the plate. Okay, so this is the oceanic crust. This is the continental crust. This is the upper part of upper mantle, uppermost part of upper mantle. Together is one plate. What exists below the plate? asthenosphere is not discontinuous, right? Like it is continuous. On asthenosphere, there are many other plates which are moving, which are present. Okay, Leeuwenhoek moving. This is like asthenosphere. Okay, if I were to draw asthenosphere here, here comes the asthenosphere. There is no discontinuity within asthenosphere. It's a single part. It's a semi-solid, semi-liquid state. Everywhere it is there. It's like a cushion. Okay, if you want me to draw another plate here, you can add that also. This is asthenosphere continuously. It is there. Here you can imagine another plate. It may be another oceanic part. Here may be another plate, maybe the continental part itself, like this. So this is what is plate. This is one plate. Okay, so यहाँ से यहाँ तक. This idea of plate was given by J.T. Wilson in 1965. The idea of plate was given by J.T. Wilson in 1965. Therefore, गलती से भी प्लेट का वर्ड यूज नहीं करना है सी फ्लोर स्प्रेडिंग थियरी में और कॉन्टिनेंटल ड्रिफ्ट थियरी में. बहुत पुराना है. प्लेट का आइडिया ही बाद में आया है. Should never use the term plate while discussing the sea floor spreading theory. If the question is exclusively on sea floor spreading theory, don't discuss plate. Okay, so if the question is exclusively on continental drift theory, again you should not use the word plate. Only when there is a comparison, then you can use, or when there is a discussion on the plate tectonics. It came in 1965. हाँ आएगा. अभी शुरुआत है. चलो डाउट बाद में रखते हैं. Okay, we'll keep all of this in the end. Once we complete plate tectonics, most of the doubts will be cleared. If it is still there, you can ask. It's always evolving. New plates continuously gets created. Older plates continuously get destroyed, merged, recreate. Okay, so it is a continuous process. How exactly it happens? That is what we'll see. This is the idea of plate. Fine. The theory of plate tectonics was proposed by Morgan, Mackenzie and Parker. In 1967. Okay. Morgan worked independently, Mackenzie Parker worked together. Okay, both the ideas were almost similar, so we attribute this plate tectonics theory to all three together. Okay. So what exactly is plate tectonics? Tectonic means basically building movement. So as I told you earlier, these plates are hard rigid outer layer which is present on a slightly softer cushion like asthenosphere. Okay, we exert some pressure on this asthenosphere, it will melt. It will melt very easily. It's in semi-solid, semi-liquid state. So therefore these hard and rigid outer layers of plates are not fixed in its position. Okay, they are not fixed at all. Okay, so अगर नीचे थोड़ा सा cushion type है, थोड़ा सा movement में ही रहता है. And नीचे का cushion खाली ऐसे वाला cushion नहीं है कि ऊपर नीचे चलने वाला cushion नहीं है. Okay, there is a strong force which is trying to act from interior. Okay, so what we discussed earlier, there is a upward, okay, so and then convergence force, divergence force. Okay, all of these forces are acting like this, right? All such kind of forces are continuously acting from inside, and it is because of these forces the plates continuously move in different direction. Imagine there is a divergence force which is trying to push in this direction. Okay, यहाँ से divergence हो रहा है, this plate try to move in this direction, this plate try to move in this direction. Is that right? नीचे से अगर यहाँ से ऐसे पुश करने की कोशिश करो, एक प्लेट इस तरफ जा रहा है, एक प्लेट इस तरफ जा रहा है. That is what is called as divergent plate boundary. Plate boundary is the region where two different plate margins meet. Okay, this is a plate boundary. This is one plate margin, this is another plate margin. What is this margin? Oceanic margin. This is oceanic margin. This is a plate boundary. Plate boundary is the part where two parts of the plates are completely separate from each other. You can very clearly say, okay, this is separate plate, this is separate plate. This is a plate boundary. Along the plate boundary, they are in continuous motion because of the interior force. Fine? And this motion is of three types. The first motion is divergence. The plates are moving away from each other. Okay, they are moving away from each other. So this plate is moving in this direction, this is moving in this direction. This is what is called as divergent plate boundary. A plate boundary where the plate margins are moving away from each other. The second type of motion is when two plates are moving towards each other. It's possible if this can move in this direction, this can also move in this direction, and both are moving towards each other here. When two plates are moving towards each other, and that boundary is what is called as convergent plate boundary. Convergent plate boundary. This is divergence, this is convergence. And as I told you, plates are not completely horizontal flat. Okay, they are curved, usually. In many cases, when one plate is moving in this direction, another plate is moving in this direction, there is a third plate coming in this direction, there is a possibility that these two plates are moving parallel to each other. Where two plates are sliding past each other, nor towards, nor away, nor towards. It is just sliding past with respect to each other. That is transform plate boundary or parallel plate boundary. Okay, three types of plate boundaries, and all of this because of the different types of plate movement. Plates are not fixed in its position. They continuously move because of the interior forces. And now these plate movements results in the creation of new landforms. When two plates converge towards each other, there is a compression, there is a folding happening over there. Okay, so folding creates, we know, it creates mountains. When two plates diverge and move away from each other, it creates a gap in between. To fill that gap, the magma rises upwards. It creates new material again over there. There also there is creation. Whenever there is a plate movement, it always results in the creation of new type of landforms. Various different types of landforms are created here. The plate tectonics theory explains almost everything related to the landform formation. Mountains, ridges, trenches, volcanoes, islands, large group of islands. Okay, so occurrence of earthquakes, occurrence of volcanic eruption, बहुत सारा चीजों को justify करता है. All of this because of plate movement only. The study of new landforms created due to the plate movement is what is called as plate tectonics. Plate tectonics is the study of landforms created due to the plate movement. That is what is plate tectonics theory. Okay, plate tectonics theory is the study of new landforms created. Tectonic is the new landform, right? The building movements. The new landforms created due to the plate movement is what is called as plate tectonics, the study of new landforms. And whatever is happening on the surface of Earth, it is the result of these plate movements only. The plates are not at all constant, not at all stationary, they are in continuous motion with respect to each other. सब कुछ उसी के वजह से ही होगा. Mountain formation, island formation, volcano formation, earthquake occurrence. Okay, so even up to tsunami also. सब कुछ इसी के वजह से. Geomorphology का major part तो इसी से ही explain होता है. This is what is called as the plate tectonics theory. See, the evolution of plate tectonics theory is something which is gradual. It is not something radical the way the continental drift theory came. I told you continental drift theory is something revolutionary. Okay, before that the idea was there was nothing, there was no such thing, and suddenly he brings an idea and says that continents are moving, it is not stationary. लोग तो पूरा शॉक में आ गए थे. फिर थोड़ा बहुत टाइम मिला इनको शॉक ऑब्जर्व करके समझाने के लिए, इनको समझने के लिए इतना टाइम लग गया. from 1912 to 1967. Okay, finally over a period of time they were able to realize and understand, okay, this is how they are moving. This is the reason behind the continental drift. This is the reason behind the sea floor spreading. इसके बीच में बहुत सारा theories आता है. The convection current theory by Arthur Holmes. Okay, so बहुत सारा theories है. Everything contributes together, and now you stitch everything together into one understanding. That is what is plate tectonics. In fact, plate tectonics theory is still evolving. We are adding more information, more details, more aspects to it. Okay, so it is like that only. It is open-ended. So ये है हमारा plate tectonics theory. We'll discuss in detail regarding the so the plate boundaries and what are the processes which are happening and what are the causes of them. Okay, what causes the plate motion, that will also go in detail. So what is the basic difference between continental drift theory and plate tectonics theory? The basic difference between continental drift theory and plate tectonics theory. The first one is the three-layered structure. There it was assumed to be Sial, Sima, knife. There was a Sial continental crust, below that there is oceanic crust, Sima, and below that there is knife. Here it is totally different. It is not about the continental crust, oceanic crust, it's about the plate. It is basically the plate which is present over the asthenosphere. And it is the entire plate which is moving, not just one part of the continent. And the plate may contain both oceanic crust and continental crust. Even if the plate moves, it's not only the continental crust which is moving, it is the oceanic crust also moving. ऐसा नहीं है कि continents खाली इधर उधर से ऐसे move होते जा रहे हैं. It's nothing like that. It is the entire plate which moves together. So हमें तो क्या दिखता है, बस continent का ही दिखता है. The entire oceanic floor is also moving continuously. Right? So it is the plate which is moving over the asthenosphere. It is not just the continental crust moving over the oceanic crust. Okay? First major difference. Second, there it was assumed that the continents move freely without much resistance. ये सबसे बड़ा गलती था Alfred Wegener का. He assumed that there is no changes at all. They are capable of moving very freely without resistance. ये तो possible ही नहीं है. These are like hard and rigid blocks. At least वहाँ पर तो continental crust बोला था. ये तो यहाँ पर पूरा lithosphere movement में है. 100 kilometers thick layers of rocks. Definitely it is capable of offering a very high resistance. And the resistance चाहिए भी हमें. Without which you will not see the formation of new landforms. If they are freely moving smoothly, नया landform तो बनेगा ही नहीं, फिर mountains कैसे बन जाएगा? These plates offer a great resistance, and it is because of the resistance only it undergoes deformation. Plates undergo deformations in the zone of interaction. जहाँ पर interaction चलता है, whether either they are moving away or moving towards or moving across, in this region there is a continuous deformation, and that deformation creates new landforms. It is because of that the mountains, okay, ridges, trenches, सब कुछ उसी के वजह से ही create होता है. Okay, that resistance is required here. That resistance offered for the movement is required here. It is clearly explained here. The causes, as explained by Alfred Wegener, is totally inadequate. Here, thoroughly, it explains what can cause the plates to move. First of all, it is the plate moving, not just the continental part. And what causes the plates to move, it is detailedly explained using the various different causes. Various different sources are given here. All of them justify this. This is the basic idea, basic difference between continental drift and plate tectonics theory. Okay? Let's write about this. Introduction. The term plate was coined by J.T. Wilson. Okay, so please write carefully. J.T. hai, not T.J. There was another Wilson was called as T.J. Wilson. Both of them were in geomorphology only. Okay? So it's J.T. Wilson in 1965. Next point. Plates are broad and rigid segments Plates are broad and rigid segments of lithosphere which includes the rigid upper part of upper mantle and crust. Next point. The plates are in motion on underlying asthenosphere. Next. Plates are nearly 100 kilometers thick and have high rigidity and are unable to deform except in response to a very strong and prolonged force. Except in response to a very strong and prolonged force. Next. There are 7 major plates on the Earth's surface. There are 7 major plates on the Earth's surface. Pacific, North American, South American, African, Eurasian, Indo-Australian, Antarctican, and Antarctica. Okay, 7 over here. And there are many minor plates. Such as Nazca, Nazca, Nazca. Cocos, COCOS, Cocos. Philippine, etc. So please try to practice this map with plate boundaries. Okay, so it will be very helpful not only for plate tectonics theory, even for volcanism topic as well as earthquakes topic. Okay, so if not this, at least you can practice this. Okay, you know the world map. Okay, so on the world map you should be able to draw the plate boundaries. Okay, so let me draw the plate boundaries here. Okay, first you need to draw the world map, and beyond on that you should be able to draw the plate boundaries. This is one plate. This is what is South American plate. Okay, so this is Caribbean plate, and from here comes the North American plate. This is North American plate. Okay, it goes somewhat like this. And this is African plate. And here is Arabian. This is Arabian, and this is Indo-Australian. This is Indo-Australian. This is Indo-Australian. Okay, and this is Eurasian. This is Eurasian. And rest everything here you see, this part. And then this part. Okay, so from here till here, this is Pacific and this is Antarctica. Okay, so I'll give the number. This is Pacific, this is North American, South American, African, Eurasian, Indo-Australian and Antarctica. 7 plates. In between you can just fill the gaps, showing the minor plates. ये बहुत यूजफुल रहेगा आपको. So any question comes on plate tectonics, you can use this. Okay, so as well as for earthquakes, as well as volcanism. ठीक है. So थोड़ा सा प्रैक्टिस कर लो, कभी बनाते क्लास में. Okay, so ठीक है, बात करते हैं. Okay, we'll talk about all of this. ठीक है. चलो, one by one we'll discuss. हाँ, एक और पार्ट भी डिस्कस करना था ना, differences. Write the subheading: differences between continental drift and plate tectonics. Differences between continental drift and plate tectonics theory. So unlike the 3-layered structure of CL Seema knife, unlike the 3-layered structure of CL Seema knife, plate tectonics proposes that the lithospheric plates are moving over asthenosphere. Asthenosphere. Second, Wegener assumed that the movement of continent is free without resistance. Movement of continent is free without resistance. Whereas in plate tectonics, the plates offer great resistance causing deformation along the plate margin. Deformation along the plate margin. Next point. the causes of plate motion are very clearly justified. With the help of convection currents. Convection currents. ठीक है. So next, plate boundaries. Okay. Before I tell you about the plate boundary, let me tell you very quickly what is the reason behind this. I'll take it up in detail in the end, very quickly, because many of you will have this doubt in your mind. Okay, so plate movement तो हो रहा है, पर क्यों हो रहा है? ये तो सर नहीं बता रहे, क्यों सस्पेंस में रख रहे हैं? नहीं, ऐसे नहीं सोचना है. बेसिक आइडिया बता देता हूँ, सुनो. So this is what is plate. Imagine these to be the plates. And here we have the core. Okay, there is inner core and then there is outer core. कोर के अंदर जो मटेरियल है कोर के अंदर ही रहता है, इससे बाहर नहीं आएगा. There is no exchange of material between the core and mantle. Mantle is the largest layer. In fact, there is asthenosphere here, that is also part of the mantle. ठीक है? So the major force behind the plate motion or major source of energy which is causing all these changes on the surface, that is endogenetic, right? So the source of energy is basically heat. The heat which is generated in the Earth's interior. The heat which is generated, which is released from the core. I told you material is not transferred, but the heat gets transferred. The heat comes out. Heat continuously comes out from the core towards the upper part, and this heat has a tendency to escape into the outer parts. बाहर आना है इसको. In the same way, within this asthenosphere also, okay, sometimes heat is getting generated, and both the heat results in the generation of large scale currents. These currents are what we call it as convection currents. Okay, currents, convection currents are basically large scale heat which is trying to rise up. As it rises up, it will push the material upwards. Mantle के अंदर जो material है ना, उसको ऊपर push करते करते आएगा. It is not always magma. Don't imagine always in the form of magma. Even the heat is trying to move up can push the rocks in solid form too. There is an upward push. And जो push होते होते ऊपर आके जहाँ पर pressure कम होगा, फिर वो magma होके convert हो जाएगा. This kind of large scale movement of the heat through this material is what is called as convection current. Why is it called as current? Because this heat, as it rises, it gets converted into the movement of material gradually, and as it hits the lithosphere, it's like a hard rigid outer layer, it will try to block it. Okay, यहाँ से तो heat rise होके आ रहे हैं, but जैसे ये block कर लिया तो ऐसे divert हो जाएगा. Okay, the heat which is rising here gets diverted into this. Okay, first it hits this part. यहाँ पर आके hit करेगा, lithosphere को तोड़ने का कोशिश करते हैं. It'll try to block and crack the lithosphere. It'll try to crack the lithosphere. But lithosphere is very hard and rigid, right? इसको ऐसे deviate कर देगा, थोड़ा सा ऐसे, थोड़ा सा ऐसे. And this creates a small crack here. Okay, that is where it breaks the plate. यहाँ से यहाँ पर ये जो part था ना, शायद पहले एक ही plate था, अभी दो अलग अलग हो गया. Only some part of this magma comes out, because as the pressure is decreased, this heat will melt the material very easily, magma comes out. Rest, most of the heat will push the plate material in this direction. Some part in this direction, other part in this direction. What happens to the plates? Because of this motion, the entire plate gets pushed in this direction as well as this direction. What is happening? The plates are moving away from each other. Okay? This is just one part of the convection current. The way you are seeing the convection currents here, here also there may be convection current which is moving in this direction as well as in this direction. यहाँ से और यहाँ से ऐसे push होके जा सकते हैं. As it gets pushed, यहाँ पर भी crack होगा, यहाँ से भी movement ऐसे आ जाएगा. And as this plate moves in this direction, it will push the plates here as well as here. Right? Now observe this part. The convection currents coming in this direction as well as this direction converge here. As they converge, it will start to descend down. ये नीचे आना शुरू हो जाते हैं. Okay, so as they converge, it will start to descend down. As they come near to the boundary of the core, again it gets bifurcated and moves away. And now again it absorbs the heat and rises up. This is what is convection current. The Earth's mantle is made up of multiple such convection currents. Like this. ये तो हम 2 dimensional देख रहे हैं इसलिए ऐसे थोड़ा सा सिंपल लगता है. 3 dimension में इमेजिन कर लो. Okay, from the Earth's interior. Okay, so there is a very small part of the core. Outside that, there are multiple such currents in all the possible directions from the mantle hitting the lithosphere. Some of them are very big size, some of them are small, some of them are so small that they get restricted only within the astronosphere also. Astronosphere के अंदर भी हो सकता है. Okay, it's a huge complex mechanism. ये तो हमें clearly पता भी नहीं है, basic idea है बस. Because nobody has gone there. So now understand this. Because of these convection currents, here we saw that the plates are moving away. And because of the same convection currents, you can also see that in this part the plates are moving towards each other. This is a divergent plate boundary and this is a convergent plate boundary. अगर यहाँ पर एक प्लेट है इस साइड में जा रहे हैं, दूसरी उस साइड में पीछे एक और प्लेट है उसको इस साइड में पुश कर रहे हैं. नाउ दे आर मूविंग पैरेलल टू ईच अदर. ठीक है? दैट इज व्हाट इज बेसिकली प्लेट मोशन. The main force behind the plate motion is this convection currents only. This theory of convection current was proposed by Arthur Holmes. इसको हम डिटेल में एंड में बात करेंगे. Causes of plate motion, उसके साथ में और कुछ भी है वो सब ऐड करेंगे. Okay, let's talk about these plate boundaries one by one and see what exactly happens over there. How many types of plate boundaries are there? 3 types of plate boundaries. First one is divergent plate boundary. Divergent plate boundary. Divergent plate boundary is a boundary where 2 plate margins are moving away from each other. 2 plate margins are moving away from each other. In that case, there are 2 possibilities. Depending upon the plate margin. It may be an oceanic plate margin is moving away from another oceanic plate margin. This is called as ocean-ocean divergence. Another case is where a continental plate margin is moving away from another continental plate margin. This is called as continent-continent divergence. There are 2 possibilities of divergent plate boundary. A divergent plate boundary is also called as constructive boundary. It's also called as constructive boundary. I'll tell you the reason. A divergent plate boundary is also called as constructive plate boundary. There are 2 possibilities where the plates which are moving away, the plate margins which are moving away, both are ocean. It's called as ocean-ocean divergence. Where along the plate boundary, the 2 margins are both are continent, it's called as continent-continent divergence. Okay, so let's see the first one, ocean-ocean divergence. Figures are very, very important. I assume that you will draw it then and there as I make it. So this is the plate margin where there are two oceanic, this is the plate boundary where there are two oceanic plate margins, and both of them are moving away from each other. Okay, this is the oceanic plate margin and this is the oceanic plate margin. Both of them are moving away from each other. What happens if both of them are moving away from each other? This is asthenosphere. The moving away will create gap between these two plates. Okay, so in this gap the pressure decreases. As the pressure decreases, the magma rises up and fills the gap. As the pressure decreases, magma rises up and fills the gap. As the magma comes up and fills this gap, it becomes solidified. It accumulates on both the sides and gets solidified. But as the plates move away, more gap is created, more magma rises up, more magma solidifies, the older part gets pushed away. This is what is happening along the ocean divergent plate boundary. Okay, so let's go in reverse direction. थोड़ा सा पीछे जाके देखते हैं, ठीक है? मैंने बोला था the plates are moving away and the magma is rising up and filling the gap. That is not 100% true. It is the magma which comes up first. The magma rises up. Okay, so figure ऐसे ही रख सकते हैं. For explanation purpose, I'll just redraw this. आप ऐसे ही रखो, कोई बात नहीं. Finally वहीं पे आएंगे. देखो. Earlier there was only one oceanic plate. There was a single oceanic plate. There was no magma, there was no gap at all. There was no plate boundary at all. The beginning is from the rising of magma which happens from the lower part of the mantle. It is the convection currents which generates the currents of magma which rises up and then it hits the lithosphere. Is that clear? बात तो यही था ना? It is the convection current which is rising up and it is hitting the lithosphere. As it hits the lithosphere, gradually it cracks the lithosphere and breaks it apart and divides into two different parts. This is what is called as the rifting of lithosphere. It starts with the rising of magma and rifts the lithosphere and cracks it into two different parts. Earlier it was a single oceanic plate. Now it is divided into two different oceanic plates with a boundary in between. That is created by the rising currents of magma. Now what created the rising currents of magma? That is not very clear. That can happen anywhere, anytime. कहीं पे भी कभी भी हो सकता है. Okay, so that is the internal mechanism. The heat which is continuously getting generated may start to rise in any direction. कहीं से भी हो सकता है. It may start to rise over the oceanic crust also. That is oceanic plate also. It may start to rise over the continental part also. Okay, so as we speak, it may start to rise in any part of India also. अभी यहाँ पर भी आ सकते हैं. Ready रहो. Okay, it may start to rise anywhere. मतलब of course it will give enough hints. ऐसे overnight बाहर आना शुरू हो नहीं हो जाएगा, तो थोड़ा बहुत तो hints मिल ही जाएगा, तो convection current शुरू हो गया ऐसा. And that is where the ocean divergence would begin. वहाँ से शुरुआत होता है. It is the rising currents of magma as it starts to hit the lithosphere over a long period of time. It will crack the lithosphere because magma is so hot. It contains a very high amount of temperature heat in it and that will gradually melt the part of lithosphere and it will crack it completely. नीचे से शुरू होगा, पूरा ऊपर तक crack कर देगा. And it creates a small gap. Through this, the magma starts to come out. But most part of the current is moving away because of the hard resistant nature of the lithosphere. Most part of it is moving away and as they move away, it gives a push to this both the parts. Now since they are both of them are separate, they start to move very easily away from each other. Now as they start to move away from each other, this part of the oceanic floor start to accumulate more magma, क्योंकि जैसे बाहर जाना शुरू हो गया, गैप थोड़ा बढ़ गया. It allows more magma to rise up. As more magma rises up, it accumulates on both the sides, it solidifies, and it creates new oceanic plate material on both the sides. New oceanic plate material is created and it is getting attached on both the sides. And as the plates continuously move away, this rising magma creates new material and the older one gets pushed away. जितना मैग्मा आएगा उतना पुराना वाला जो प्लेट मटेरियल है ना वो पुश होते जाएगा. ओके, सो न्यू मैग्मा राइजेस, ओल्डर वन गेट्स पुश्ड अवे. ये तो कहानी कहीं पे सुना है, यही तो है सी फ्लोर स्प्रेडिंग थियरी. Ocean divergence is basically the sea floor spreading due to the mid-oceanic ridges. This is the part we call it as mid-oceanic ridge. Over a period of time, what happens? The rising magma will completely melt this part. ये जो part है ना, इसको पूरा melt कर देगा, and it makes both the edge of the oceanic part very thin. ऐसे, ठीक है, दोनों पार्ट को बहुत थिन बना दिया. इट मेक्स इट कंप्लीटली थिन एंड द राइजिंग मैग्मा विल continuously create the new plate material, and some of it also comes out. As it comes out, it accumulates on both the sides and gradually it builds a structure which we call it as a mid-oceanic ridge. This is what is called as mid-oceanic ridge. Earlier it was near to the oceanic floor only, but as the magma starts to come out and pour out, it starts to build up. It becomes solidified, right? And it starts to rise its height. Gradually now this is a separate oceanic plate, and now this is a separate oceanic plate. Both are continuously moving away from each other, and the magma is continuously rising in between and coming out. And that is building the new oceanic plate on both the sides and pushing the older ones continuously away, causing the entire sea floor to spread away from the mid-oceanic ridge. That is why it is called as constructive plate margin. It results in the construction of new plate material. What causes earthquakes? Earthquakes क्यों होता है? देखो, ये जो हम लिथोस्फीयर बोलते हैं ना, लिथोस्फीयर इज बेसिकली हार्ड एंड रिजिड आउटर लेयर made up of multiple layers of rocks. As these rocks layers move away, okay, one part is moving in this direction, another part is moving in this direction. Within the rock layers there are joints and cracks. Imagine the entire part moving. Within that there is some kind of friction, and during that energy gets trapped, and as they are trying to move, the energy sometimes will build up. Okay, they are trying to move. As the energy builds up, sometimes it will stop the position of this, stop the movement of these rocks. Okay, and in that case energy starts to build up, and at one point of time it just snaps and then moves ahead. Wherever there is a plate motion, there is a chance of building up of energy. And that kind of build-up of energy happens very easily near to the plate boundaries. Plate boundaries के पास में बहुत easily हो जाते हैं. Therefore, earthquakes are always observed near to the plate boundaries. Why do we have the eruption of magma near to the mid-oceanic ridges? It is not just the magma which is coming from the melting of the plate. Okay, so it is the magma which is coming from the innermost part of the mantle in the form of convection current, which is rising up through the asthenosphere and then hitting the lithosphere, and the same magma is coming out. It is basically the same magma which is responsible for the divergence of the plate. ठीक है? And this magma is responsible for the creation of new plate on both the sides, which will push the older one away, causing the sea floor spreading. It is not only causing the sea floor spreading, it is at the same time creating new oceanic crust on both the sides. So that is the reason behind volcanic eruptions along the mid-oceanic ridges. And if you talk about the earthquakes, earthquakes are always divided into three types depending upon the depth at which the energy is being released. जिस लेवल पे एनर्जी रिलीज हुआ है, जिस डेप्थ पे एनर्जी रिलीज हुआ है, दैट इज व्हाट डिसाइड्स द टाइप ऑफ अर्थक्वेक्स. Three types of earthquakes. One is shallow, another one is intermediate, third one is deep. Shallow earthquake is the one which happens at the depth between 0 to 70 kilometers. Okay, if the depth of this earthquake is somewhere here from the surface up to 70 kilometers, this is called a shallow earthquake. Intermediate is one which happens at the depth between 70 to 350 kilometers. Deep is more than 350 kilometers. Now tell me, if earthquake happens along the ocean divergent plate boundary, which type of earthquakes it will be? What is the thickness of plate? It is always shallow. Okay, it is always shallow earthquake because the plates are not deeper than 100 kilometers here. Already ridge के पास में और thin हो गया. It is always less than 70 kilometers. ठीक है? Earthquakes are always shallow. Earthquakes happen frequently near to the ridges. It is because of the moving plates. As the plates move away from each other, they are very, very slow movement. Okay, so they are measured in centimeters per year. 3, 4, 5, 6, 7, 8. Fast है तो around 8 centimeter, slow है तो around 3 centimeter. Okay, per year. But it can be measured through satellite imagery, satellite observation. We can very clearly come to conclusion. ये है ocean divergence. ठीक है? Let's write about this. Ocean divergence. The plate margin is a zone of tension. Is a zone of tension where lithosphere splits, separates, and moves apart in two opposite directions. Next point. Along ocean divergent plate boundary, the magma comes up through the cracks. Magma comes up through the cracks and solidifies, leading to formation of new oceanic crust. Leading to formation of new oceanic crust. Next point. The continuous build-up of solidified magma results in the formation of results in the formation of mid-oceanic ridges along the plate margin. In this plate boundary, as the oceanic plates, as the oceanic plate margins move away from each other, it causes the spreading of sea floor. Next point. Shallow earthquakes with focus up to 70 kilometers are observed. Up to 70 kilometers are observed near this plate boundary. Near this plate boundary. So what is the reason behind the ocean divergence? The rising currents of magma, convection currents, okay, so which is trying to push them away. And शुरुआत हुआ था rising current से ही. उसके पहले same plate था. It was the same plate which will get bifurcated into two different parts. When there was a oceanic plate, the rising currents of magma will bifurcate into two different parts. Gradually this becomes one part, and this is another part. This part starts to move away from this part. This is what is ocean divergence. ठीक है, यहां पर जो क्रैक दिखता है इसी को हम बोलेंगे मिड ओशनिक रिड्ज. सो यहां पर अर्थक्वेक्स होगा, यहां पर पूरा अर्थक्वेक्स होगा. ये है हमारा ओशन डाइवर्जेंस. सो इंस्टेड ऑफ oceanic plate, imagine a continental plate. Instead of oceanic plate, imagine a continental plate. Here the rising currents, यहाँ पर भी chance है, मैंने बताया ये कहीं पे भी हो सकता है. The rising currents of magma as part of convection currents may start to rise below a continental crust also. In that case, it creates continent divergence. Simple. ठीक है? Why will it not create ocean continent divergence? It's a very rare possibility that the rising magma rises exactly at the border between continental crust and oceanic crust. It's a very rare possibility. It's just, as I told you, it is purely accidental. कहीं पे भी हो सकता है. Convection current आते आते उसको पता भी नहीं ऊपर क्या है. So why will it go exactly near to this part where there is oceanic and continental margin? तब भी हो सकता है ना. On one side there is oceanic, another side there is continental. It's a very rare chance. As such, there is no ocean continent divergence. I am not saying this is impossible. It's a very rare chance. ठीक है? So what happens when it rises below the continental plate? That is what is continent divergence. Very similar process, but there are some slight differences are there. So next one, continent divergence. There are 3 stages inside continent-continent divergence. The first stage is intracontinental rifting. इंट्राकॉन्टिनेंटल रिफ्टिंग, वही सेम पार्ट था, वहां पर ओशनिक क्रस्ट सिंगल था, यहां पर कॉन्टिनेंटल क्रस्ट सिंगल है. देयर इज अ सिंगल कॉन्टिनेंटल क्रस्ट एंड बिलो दैट देयर इज asthenosphere. Here the rising currents of magma will start to hit the lithospheric plate and gradually the continuously rising currents will crack this. ऐसे नीचे से crack होते जाएगा. Over a long period of time, the rising currents of magma will be able to crack this. It will take slightly longer time than the oceanic plate because continental plate is made up of continental rocks, which is thicker as well as harder, lighter in density, but harder because of the buoyancy. It is resistant. It's because of that it is difficult to crack it, but it will crack it. Magma के साथ में तो कोई पंगा नहीं ले सकता है. Finally तो crack हो ही जाएगा वो भी. This stage is what is called as intracontinental rifting. Okay, intra, within. Within the same continental plate, there is a rifting has happened. So gradually the magma will rise through this gap and starts to come out. Okay, magma eruption started here. This was the same continent which will get separated. What happens to this magma? This is the currents of magma. Some of it part gets diverged here, some of it here. That will also start to push both the sides of the continent away from each other. देखो नीचे से force imagine करना. You have to imagine this force. As this force try to move away, it will try to push this side, this part along this side, this part along this side. Some of the magma try to rise up. As the magma rises up, it starts to break these rocks. Continental rocks है ना, इतना easily break down नहीं होगा. Okay, ऐसे cracks होगा, blocks होगा. Okay, so multiple cracks and multiple blocks are formed here. They are very hard and resistant to break. The nature of the granitic rocks are somewhat like that. Over a period of time, you will see the formation of a huge cracked blocks. Okay, ऐसे. Magma is trying to come out through that. Here and there it comes out. Okay, इसको side में रखते रखो. So this is what is magma. It is trying to come out. Gradually this cracking creates a valley over there on top of it, which we call it as Rift Valley. When two continental parts, the same continental plate cracks into two different, along the region of that crack, you will see huge blocks. Okay, blocks are created due to the faulting activity, right? This is also kind of faulting activity only. Along that, a series of such faults get created, series of blocks get created, and it gets elongated all along the length of this entire plate border. That is what is called as Rift Valley. This is the first stage. Formation of Rift Valley. Of course, Rift Valley has magma coming up from here and there. Okay, some of the magma comes out, and some of the magma which accumulates here may erupt along the sides of this location. यहाँ पर आके यहाँ पर ब्लॉक हो गया, फिर यहाँ से आके यहाँ पर eruption भी हो सकता है, यहाँ पर एक magma volcano भी बन सकता है. Okay, surrounding area में volcanoes बन जाएगा. Because the hard rocks of the lithosphere within the continental crust will try to block this magma. Can you see this part? This is continent, this is continent. The rising currents of magma will break this part and forms this kind of valley. That is what is called as Rift Valley. ठीक है. The best example of rift valley at this stage, first stage में जो rift valley है वो है हमारा ईस्ट अफ्रीकन रिफ्ट वैली. It's very clearly visible even in the satellite imagery also. Come to the eastern part of Africa. Okay, let's remove the boundaries. Can you see this part? If you observe, you can see a huge crack. All these lakes are basically the part of this crack which is filled with water. Can you see this? There's a huge crack. This was the part of the single continental crust, and now this has become separate, this has become separate, and both of them are trying to move away from each other. There's a huge convection currents, the magma which is rising up here below this part, and this rising magma is trying to come out here. Everywhere you will find volcanoes, here, 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 surrounding में बहुत सारा volcanoes है. The rising currents have started to break this apart. It is just beginning. It is in the first stage only. This huge valley is what is called as East African Rift Valley. Okay, so this is the actual on the ground pictures. Can you see this? The Rift Valley. This entire part is cracking. It will take few million years, depends upon the speed of the convection currents. Okay, so and how intense the convection currents, or it may even stop also. Not sure. Okay, if it is continuous, then only it will continue to move away. If it continues, what happens? After some time, it enters the second stage. The second stage is interplate thinning. Interplate thinning. Now by now this is two separate plates. Earlier it was same plate, therefore we use the word intracontinental. Now both are separate. This is one separate plate, this is another separate plate. ठीक है, ये वाला फिगर हो गया. So I assume हो गया. इसी में दिखाता हूँ, फिर दोबारा बनाएंगे. देखो, when the magma is continuously rising, you don't have to do this, we'll draw this separately. When the magma is continuously rising here, it will start to melt the rocks. यहाँ से आएगा, यहाँ पर hit करेगा, यहाँ पर hit करेगा. It will start to melt these rocks. Magma is capable of melting these rocks very easily. Gradually what happens? It will start to melt both the edges of continents like this. दोनों को melt करते जाएगा. And as the plates move away, more gap is created in between. More magma rises up, more magma causes faster melting of both the edges like this. Okay, ऐसे 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 gradually. देखो ये पूरा clear हो जाएगा. The entire plate will get melted completely like this. फिर पूरा के पूरा large scale में magma आएगा, फिर पूरा दोनों को push करते जाएगा. After some time, we will have somewhat like this. Both the edges of the continental plates have got completely melted. To become somewhat like this. Okay, earlier it was a single continent. देखो ये इतना ये खा जाए है. Okay, इतना सारा खा के खत्म कर दिया इसको, continent को. Now the rising magma is forcefully coming out and pushing both the sides apart. This is pushing this side, this is pushing this side. ठीक है? At the same time, it is also trying to move in this direction too. There's huge currents of magma coming out. This will push the continents, this continent on this side. What happens to this magma which is coming out here? This magma continues to accumulate and solidify here. यहाँ पर आके बीच में जो गैप क्रिएट होते जा रहा है ना, उसमें अक्यूमुलेट होके सॉलिडिफाई होते जाएगा. The earlier rift valley has become very, very wide depression here. It becomes so wide depression. Now a part of the ocean water enters and fills this gap. This entire part gets filled with the ocean water. It's a very shallow depression. It creates a shallow sea. In between, a sea gets created. Earlier there was just a rift valley. As the valley widens, from one side the ocean water enters and fills this gap. Okay, completely यहाँ पर आके ocean water fill हो गया, accumulate हो गया. Now both the parts are sufficiently apart and in between a sea has got created. With this, the plate starts to move much faster. Because earlier when the gap was limited, okay, so there was a limited flow of magma and then there was limited movement of the plates. Now with the wider gap, more magma comes up and faster movement would start to happen. And both the continental parts starts to move away from each other. As they start to move away from each other, this gap starts to widen and the sea starts to widen. The best example for this, for the second stage, is the present day Red Sea. 20 million years ago, the Arabia was attached with Africa. There was no Rift Valley also. It was completely part of Africa. In the first stage, a development of Rift Valley would happen through intracontinental rifting. The way there is a Rift Valley here, जैसे यहाँ पर अभी Rift Valley है ना, वैसे यहाँ से Rift Valley develop हुआ था. Okay, as the Rift Valley started to widen up, okay, from here the ocean water entered and filled this gap. Now the Rift Valley has sufficiently widened up and the ocean water has filled this entire gap. This is what is called as Red Sea. It is in the second stage. Okay, it is in the second stage where both the parts of the continents have sufficiently moved away. Now this is a different part, this is a different part. In between there is a shallow sea. Can you see this crack? You can still see this crack. Okay, this and this. It is still active. Magma is still continuously coming out. As it comes out, it comes in contact with the water, it cools and solidifies. There only it gets attached and it gets further pushed away. Okay? This is the second stage. Red Sea is the best example of second stage. If you give time, what happens? The rising magma will push both the sides sufficiently apart and it continuously accumulates in between. That is our third stage. Okay, so I'll just redraw this. This was the second stage. टेक्नोलॉजी यूज कर लो. आप तो नहीं कर सकते, मैं तो कर सकता हूँ. ठीक है, ये था हमारा सेकंड स्टेज. ठीक है, दिस वाज द कॉन्टिनेंटल क्रस्ट, दिस वाज द कॉन्टिनेंटल क्रस्ट. बीच में यहाँ पर मैग्मा आके राइज हो रहा था. एज द मैग्मा इज राइजिंग अप एंड पुशिंग इट अपार्ट, ओवर ए लॉन्ग पीरियड ऑफ टाइम व्हाट हैपेंस? This part moves in this direction. This part moves in this direction. ठीक है, तो पूरा दूर दूर चला गया. इतना गैप तो क्रिएट हो सकता है क्या? बिल्कुल नहीं हो सकता है. See, the magma as it is rising, it starts to accumulate, it starts to build and solidify here. It creates new crust itself over there. It is slowly building the crust and that is what is causing them to move. ऐसे हवा में तो नहीं जाएगा ना. जहाँ से मैग्मा आ रहे हैं देखो उसी जगह में देखते रहो. This is the newly formed crust. It is just continuously building up, building up. Over a long period of time, both the continents will move sufficiently away from each other, and in between, gradually, the new crust would get developed. The magma is still rising over there and trying to push both the parts continuously away from each other. The earlier shallow sea has become a wide ocean. The part where the magma is coming up, it is still coming up, and over a period of time it builds a ridge, which we call it as mid-oceanic ridge. So it is the magma which is coming in the same place, and both the plates, continental plates, have moved away from each other. And this continuously rising magma has created the oceanic crust over a period of time. Now, why oceanic crust? Why not continental crust? Oceanic crust is made up of which type of rocks? Basaltic rocks. Continental crust is made up of granitic rocks. Oceanic crust, basaltic rocks is denser. Continental crust, granitic rocks are lighter. The magma which comes from interior of the earth is obviously denser. And that always creates oceanic crust, that always creates basaltic rocks only. Okay, so the magma which is coming from the interior cannot create lighter density granitic rocks. And these basaltic rocks over a period of time accumulates, and that builds up oceanic crust only. Okay, so therefore, in between two different continents, a new oceanic floor with oceanic crust would get created. And on this part, this has got attached to this side. This has become one plate. There is no plate boundary here. This is completely one plate. On this side, the newly built oceanic crust will get attached to this side, and now this is another different plate. And in between, there is a plate margin. The rising magma will build up, and that creates a ridge in between. So finally, it has resulted in the formation of a mid-oceanic ridge. That is the third stage. Formation of mid-oceanic ridge. This is magma, and this is oceanic crust. Okay, so this is also oceanic crust. So पहले एक्चुअली कॉन्टिनेंट था, सिंगल कॉन्टिनेंट डिवाइड होके दो कॉन्टिनेंट बन गया. जैसे जैसे दो कॉन्टिनेंट अलग अलग मूवमेंट होना शुरू हो गया, बीच में आ गया ओशनिक क्रस्ट. एंड ओशनिक क्रस्ट बढ़ते गया बढ़ते गया बढ़ते गया, दोनों साइड से आके नया क्रस्ट क्रिएट हो गया विथ मिड ओशनिक रिड्ज. नाउ यू अंडरस्टैंड व्हाई इट इज कॉल्ड एज मिड ओशनिक रिड्ज. This ridge is usually present at the central part of the ocean, which has got newly created. ये equally create हुआ है ना दोनों side में. If you see the entire ocean, it is always at the central part because both the sides are newly created at the same rate. यहाँ पर जितना addition हुआ है उतना भी यहाँ पर भी addition हुआ है ना. Therefore, it is always at the center. Therefore, it is called as mid-oceanic ridge. The best example for this is the Atlantic Ocean. Okay, so here you can see this is our South America. Okay, so the earlier South America was here. Okay, can you see the shape of the ridge also? Very clearly you can identify. This was our South America. Okay, Africa was here. Okay, somewhat like this. First, it developed a crack here. Earlier, it was a single part of Gondwana. It was single part of Gondwana. If you go back before that also, there was a single supercontinent of Pangaea. The single supercontinent of Pangaea broke into two different parts. Towards the north, the Angara land; towards the south, Gondwana land. The rift developed was the Rift Valley. As the Rift Valley developed, Rift Valley widened, it created a shallow sea in the second stage. What is that sea? Tethys Sea. Tethys Sea was created between Angara land and Gondwana land. Okay, first the rift develops and then the rift widens, right? And as the rift widened, both the part became separate. Now from the Gondwana land, another rift develops north-south that will separate South America and Africa. First the Rift Valley will develop, Rift Valley widens to develop a shallow sea. As the sea widens, both the parts continuously move away from each other. This moves in this direction. ये जितना जाएगा उतना ये भी जाएगा. Because the oceanic floor is created at the same rate. Gradually the Africa has come here, South America has come here. In between, the entire Atlantic Ocean is a newly formed ocean. That is why Atlantic Ocean is the youngest ocean on the surface. It is the youngest ocean of the world, which was created in the last 200 million years only. उसके पहले है ही नहीं था. This entire oceanic rocks are newly created with mid-Atlantic ridge in the center. So basically the third stage of continent-continent divergence is ocean-ocean divergence only. मतलब continent-continent divergence से शुरू होके भी ocean-ocean हो सकता है या ocean-ocean independently भी हो सकता है. It is possible independently also. Any example? यहाँ पर देखो. Between the Nazca plate and Pacific plate there is a ridge here. Okay? इसमें देखो. Between the Nazca plate and Pacific plate, there is a ridge here. Both of them are moving away from each other. This is ocean-ocean divergence. So now you understood why the breakup of Pangaea happened. So बेचारा अल्फ्रेड वेगनर को इतना पता नहीं था सी फ्लोर स्प्रेडिंग के बारे में. इसलिए जैसे सी फ्लोर स्प्रेडिंग पता चल गया हमें क्लियर हो गया. Therefore, sea floor spreading is considered to be the connecting link between the continental drift and plate tectonics. Through sea floor spreading, we can understand why the continents would move away. It is not the continent which are actually moving away, it is the entire plate which is moving away, and in between there is a rift valley ridge formation which is causing both of them to get continuously pushed away from each other. सारा continents का divergence ऐसे ही होता है. अगर शुरुआत करो continent से, breakup होगा, फिर separate होगा बस. This is what is continent divergence. And earthquakes, all of them are shallow earthquakes only. Because still here, even here also it is thinner. And the interaction is always limited to the surface. Earthquakes happen here also. East African Rift Valley also known for earthquakes. All of them are shallow earthquakes. Magma है, volcanism भी है. Yes, wherever there is magma is rising up, volcanism, volcanic activity is also observed. So ये है हमारा continent divergence. Is that clear? So 3 stages. So draw this if at all you are not drawn. So we'll continue after the break. So please write about this continent divergent boundary. Continent divergent boundary. Formation of divergent plate boundary. Formation of divergent plate boundary. Along continents involve 3 stages. First one, intracontinental rifting. Intracontinental rifting. Okay, so within that, the upward movement of magma below a continental crust causes the fragmentation of continent through creation of numerous cracks and faults. Creation of numerous cracks and faults. Due to stretching of crust. Creating rift valley. Next point. Rising magma starts to come out. Through this rift. For example, East African Rift Valley. Second stage, interplate thinning. It involves partial melting of lithosphere. And gradual thinning of continental crust. Next point, Rift Valley starts to widen. And gradually get filled with ocean water. Resulting in the formation of a shallow sea. Example, Red Sea. Third, formation of mid-oceanic ridge. The continuous spreading of continental plates away from each other away from each other, and creation of new oceanic crust. Creation of new oceanic crust along the Rift Valley. By the rising magma. By the rising magma. Pushes the continental mass. Pushes the continental mass sufficiently apart. Pushes the continental mass sufficiently apart. Next point. At this stage, there will be a new oceanic basin along both the sides of the ridge. Can we say that there are two types of mid-oceanic ridge, one from ocean, another on continent? Though there's not much to differentiate as such, both are very similar. Since on both the sides there is oceanic crust only, okay, so it is almost same. There's not much difference at all. Why is the plate not melted at the stage of rift formation? It starts to melt. It is a very slow process. It takes longer time. It will not completely melt. It is just partial melting. Because as some part of it is melting, it gets pushed away. So there is no need to completely melt it as such. Can we say Narmada Rift Valley also is a rift valley for after a few million years? Yes. No, Narmada is not an active rift valley. It is just a small rift valley, which is incomplete. Okay, so there's no magma eruption over there. It's a different type of rift valley. Okay. So next, convergent plate boundary. It is also called as destructive plate margin. Destructive plate boundary. In that, first one is ocean convergence. So imagine the continents which are present here in one side. Imagine the Pangaea was here somewhere and it starts to move away. Okay, the continents were here, they start to move away like this. So as the continent starts to diverge, in between new oceanic crust would get created. Right? It is causing the entire continents to move away in different direction. Okay, if this was all a single continent and in between the new oceanic crust is getting developed due to the divergence of continent and continent, what happens to this oceanic crust which is behind? Because Earth cannot become bigger. It's just the outermost thin layer. Just because of that, the Earth cannot become bigger in size. As it starts to move away, the movement of these continents away from each other will push this oceanic crust towards each other. Okay, so when two continents are moving away from each other like this, पीछे से देखो यहाँ से जो ऑलरेडी ओशनिक क्रस्ट है वो एक दूसरे की तरफ पुश होता है. So divergence in one side causes convergence in another side. And if that convergence involves two oceanic plate margin, that is what is called as ocean-ocean convergence, very simple. The cause of divergence is the rising of magma. The rising of magma convection current is the cause of divergence. The cause of convergence is divergence itself. You don't need magma convection currents here. Of course, here also they will also join, but this is the divergence which is pushing from the other side will cause them to converge. When two different plates, okay, so पहले से ही वो अलग था. ऐसा नहीं कि वो convergence की वजह से अलग हो गया. They were already separate. There was a plate margin. There was no movement at all. Okay, when you try to push them along the plate margin, they will start to converge towards each other. Okay? If this is an oceanic plate, okay, this is one oceanic plate, this is another oceanic plate. Okay, so as they start to move towards each other, what happens? One of the oceanic plate will start to undergo subduction below another. That moving down is what is called as subduction. That is the only possible. You cannot expect the plate to move one above another. Why will it not happen? Even if it happens finally, this is the result only. Either this plate goes down or this plate goes up. The result is same. Because below both the plates, there is asthenosphere. This is all asthenosphere. Asthenosphere is denser. Is that right? As two plates starts to converge on this denser medium, so the convergence causes one of the lighter plate. Both are lighter only. Okay, so one of the plate material to get pushed downwards. दोनों लाइटर है. एस्थेनोस्फीयर के कंपैरिजन में दोनों लाइटर ही है. Among them, whatever is the lighter, it will push the denser one below it. This is oceanic plate, this is oceanic plate. Imagine this is slightly denser, this is slightly lighter. Okay, let's keep it otherwise. Imagine this is slightly denser and this is slightly lighter. इसका डेंसिटी थोड़ा सा ज्यादा है, ये थोड़ा सा हल्का सा है. When both of them try to move towards each other, the denser one gets pushed downwards. Okay, the denser one will get pushed downwards like this. As the lighter one is present above this denser one, the denser one will get pushed downwards like this. Why the denser one gets pushed downwards? Here comes our isostasy. In isostasy, we studied that there is a greater push. Buoyancy force is there. Lighter the material, greater the buoyancy. Okay, so lighter it is, greater the buoyancy. When two plates are converging, which one has a greater chance of undergoing subduction? The one which is denser. Because the lighter one, if you try to push down, the more it rises up. Okay, so imagine there is water and in that you are given a wooden plank and there is a sheet of iron. Okay, so sheet of iron. You try to push the iron plate down, will it go down? Very easily it goes down. You try to push the wooden plank down. अब जितना push करोगे उतना ऊपर force आएगा. Even though it is lighter, it is difficult to push it down. Is it right? जितना दबाने की कोशिश करोगे उतना ऊपर buoyancy force आएगा. ये भी ऐसा ही है. जो lighter है buoyancy force की वजह से हमेशा ऊपर ही रहेगा. Heavier को नीचे दबा देगा. It gets pushed down. Finally, it is the heavier one which gets pushed down, and the lighter one, it is the buoyancy of this which will push this down. इसको नीचे नहीं दबा सकते हो. इसी की वजह से ये नीचे चले जाएगा. That is the contribution of buoyancy force in plate movement. It is the buoyancy, the lighter material of the other plate, and whose buoyancy will cause the denser one to get pushed down. इसका जो force है ना, ये इसको ऐसे नीचे दबा देगा. ओशन कॉन्टिनेंट में और क्लियरली समझ आएगा ये. Okay, so there the buoyancy is much more higher. इसलिए ओशनिक प्लेट तो आराम से सबडक्ट हो जाएगा वहां पर. Here both of them are ocean, one of them is denser, another one is lighter. The denser one gets pushed down and the lighter one moves up. The final result is one plate moving down below another. What happens if one of the plate is getting pushed down? It will get pushed down into the asthenosphere. Asthenosphere is where the temperature is higher. Higher temperature will gradually start to melt it. As it starts to melt, it will become part of the asthenosphere. The convergence of two different plates causes one of the plate to undergo subduction. This process of getting pushed down is what is called a subduction. Subduction causes this plate to undergo melting and gets assimilated into the asthenosphere. It will get assimilated into the asthenosphere. As it gets assimilated, there is huge process which is involved. That is what is convergent plate boundary. What exactly happens in convergent plate boundary? Along ocean convergent plate boundary, the oceanic plate of higher density will start to undergo subduction. The process of moving down is what is called a subduction, whereas the oceanic plate of lower density remains upwards. During the process of subduction, the subducting plate creates an unusually deeper part of the oceanic floor. Okay, इसको बना के दिखाओ दोनों को. If this is the normal oceanic floor, यहाँ पर एक प्लेट खत्म होगा. ये दूसरी प्लेट है, इसका नॉर्मल ओशनिक फ्लोर है. जहां पर ये सबडक्ट होगा, ऑब्जर्व करो, ये ऐसे जाएगा ना. This is where we have the water level. The subduction creates unusually deeper layer. This is the average depth 4000 meters. This is the average depth 4000 meters. This is more than double, 10,000 meters. Okay, 11,000 is the deepest. This unusually deeper parts of the oceanic floor, which is created due to the subduction of one oceanic plate below another, is what is called as trench. इसी को ही हम बोलते हैं trench. देखो ये नॉर्मल ओशनिक फ्लोर है, नॉर्मल ओशनिक फ्लोर है, 5000, 3000, 4000, 5000 मैक्सिमम, उससे ज़्यादा नहीं होगा. बट जहाँ पर ट्रेंच आ जाएगा 10,000, 11,000 meters. The deepest parts of the oceanic floor is getting created along the regions of subduction. Okay, here you can see from the normal oceanic floor it is very, very deeper. And these parts are what we call it as trench. इसी को हम बोलेंगे trench. And trench is there all along this entire length where the plate is subducting, because plate is not just this part only, right? This is the entire plate which is subducting below this plate. And wherever it is subducting, it creates all along the length a trench. Along the plate margin, you will find a trench. The presence of trench is an indicator, okay, there is subduction happening here. What happens along the trenches? Trenches तो बहुत खतरनाक जगह है. ऐसे क्यों? Because the subducting material, subducting plate, as it gets pushed down, it is experiencing intense compression, intense heat. The temperature and pressure changes will change the nature of the rocks. It will get pushed down. As it gets pushed down, the rocks experience this greater compression. This is not very smooth movement, right? It is a very hard and resistant part. It is not moving down, it is getting pushed down. Many of the times they get interlocked. The rocks are not moving, but there is a force which is pushing. What is the force which is pushing here? The ridge. पीछे से ridge तो develop होते ही जा रहा है ना, ये तो push करेगा. तो जितना मटेरियल यहाँ से आ रहे हैं वो तो पुश करते जाएगा, ये तो मतलब ये तो आगे जा रहे हैं, बट कभी कभी आके ये ऐसे अटक जाते हैं, इट गेट्स स्टक, द एनर्जी जस्ट बिल्ड्स अप एंड समटाइम्स इट जस्ट सडनली स्नैप्स. ओके, इट इज नॉट अ वेरी स्मूथ मूवमेंट, ऐसे जर्क 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 ऐसे होगा. ओके, दो जर्क के बीच में बहुत ज़्यादा टाइम गैप रहेगा, जब जर्क होगा तभी अर्थक्वेक होगा. दैट इज व्हाट इज अर्थक्वेक. As it moves down, it gets stuck and suddenly it releases the energy. That can happen anywhere. यहाँ पर, यहाँ पर, यहाँ पर, यहाँ पर, all the depths till the plate is completely melted. A plate descends down up to nearly 700 kilometers before it gets completely melted. इसका thickness है 100 kilometers. It goes into up to 700 kilometers before which the temperature is too high and it completely melts. So earthquakes are experienced up to the 700 kilometers of depth. Therefore, you will experience all the three types of earthquakes: shallow, intermediate, and deep. Okay? Along the plate boundary where two plates are converging, and if there is subduction, you will see one of the most frequent earthquakes. जहाँ पर convergence होगा, ज़्यादा टकराए होगा ना, ज़्यादा energy build-up होगा. One of the most frequent earthquakes. Divergence तो बहुत easily हो जाएगा, आसान से होता है. They are not very intense earthquakes, but convergence, there is a very strong intense earthquakes at all the depths. What happens to this plate which is undergoing subduction? It is gradually experiencing change in the temperature and pressure. What happens if you change the temperature and pressure? Metamorphism happens first. पहले तो इतना easily तो melt नहीं होगा. The rocks, as they get compressed, temperature changes, pressure changes, and metamorphism happens. You will see the presence of a strong metamorphic rocks here. But even beyond that, if you are continuously compressing them, there are huge amount of material, huge amount of rocks, different nature of rocks. Some of the minerals, some of the rocks melts slowly. Some of the minerals, some of the rocks melts faster. Each of them have their own melting temperature, right? So within this part, some of the rock starts to melt faster. ये पूरा solid है, उसके अंदर थोड़ा थोड़ा सा melt होना शुरू हो गया. That is what is called as partial melting. The complete melting happens here at a very deeper depth, but the partial melting starts much before that because of the melting of some of the rocks and minerals with lower melting point. And the partial melting also generates magma. Gradually, the magma starts to get built up due to the partial melting. And this partial melting, since it is melting earlier, they have lower melting point. And they are also of lower density. इतने rocks के अंदर, some of the lower density materials, some of the lower melting point rocks will start to melt faster, and because of their lower density, it starts to rise up. बाकी सारा जो material है वो higher density है, इसका lower density है, वो अपने आप ऊपर आना शुरू हो जाता है. The magma starts to rise up. As this magma rises up, it starts to accumulate on the other oceanic plate. ये जनरेट हुआ था इस ओशनिक प्लेट के अंदर, आके अक्यूमुलेट हो रहे हैं दूसरी ओशनिक प्लेट के अंदर. और जितना ये सबडक्ट होते जाएगा उतना मैग्मा आते आते ही रहेगा. पार्शियल मेल्टिंग इज कंटिन्यूअस. मोर एंड मोर मैग्मा बिल्ड्स अप इन दिस प्लेट, द प्रेशर बिल्ड्स अप एंड एरप्ट्स आउट ऑन द ओशनिक फ्लोर. ओशनिक फ्लोर के ऊपर वॉल्केनिक एरप्शंस होगा. And as the magma is continuously building up, volcanic eruption continues, and this process happens over millions of years of time. And finally, this volcano will rise even above the water level. Ocean floor से शुरू होके पूरा ऊपर तक build up हो जाएगा. Millions of years of time is there. And finally, when it rises above the water level, that is what we call it as a volcanic island. So if you observe all along the trenches, you will always find volcanic islands on the other side. That shows in which direction the subduction is happening. If the volcanoes are here, that means this plate is subducting. If the volcano is on this side, that means this plate is subducting. And you will see all along the length of the trench, there is a continuous line of volcanoes. And usually trenches are arc shape. Okay, trenches ऐसे arc shape में रहता है, because the movement is not uniform everywhere. यहाँ पर ज़्यादा है, यहाँ पर कम है, यहाँ पर ज़्यादा है. Over a period of time, it becomes arc shape. Since the trenches are arc shaped, these volcanic lines are also arc shaped. They are called as island arc. Arc shaped islands. On the other side of the trench, you will see continuous formation of island arc due to the continuous volcanic eruption which is happening. जितना ये subduction होता ही रहेगा, यहाँ पर उतना magma generate होता ही रहेगा, and volcanoes तो बनते ही रहेगा. They are all active volcanoes. ये पूरा active volcanoes ही है. It continuously builds up on this side. Okay, intermittently erupting and then stopping, again erupting, again stopping. Sometimes in some places the subduction, imagine the subduction rate is faster. The magma generation is also faster and huge amount of magma would get generated. In that case, large group of islands will be formed on this side. Not just one volcanic line. A large group of islands will be formed if there is an intense melting of plate. Intense partial melting. And that large group of islands which are formed are what we call it as archipelago. इसको बोलते हैं archipelago. ठीक है? The partial melting generates magma which is lighter in density. It accumulates on the other oceanic crust, oceanic plate. Gradually the pressure builds up. Once the pressure builds up, finally it erupts on the oceanic floor, creating volcanoes which are called as sea mounts. What are sea mounts? Mountains on the oceanic floor, volcanic mountains. But due to continuous eruption, they continuously rise, build up over a period of time. It rises even above the water level. That is what we call it as volcanic island. Such a series of islands arranged on the other side of the trench is what is called as island arc. Island arc, arc-shaped line of islands. And if they are formed in large group, it is called as archipelago. Archipelago. Wherever we have ocean convergent plate boundary, these are very, very common. These are the common features. Trench formation, partial melting, sea mounts, volcanic islands, island arc, and archipelago. And this subduction creates earthquakes at all the depths. After certain depth, you will start to see a large number of earthquakes concentrated in a specific area. Why? Because pressure is not very great near to the surface, and as the plate melts, pressure becomes lesser. नीचे जाते हुए pressure कम हो जाएगी क्योंकि पूरा melt होते जा रहे हैं. At one particular depth, you will find higher pressure. पूरा दब गया, पूरा intense compression है. So therefore, higher number of earthquakes originate from this zone, and this particular zone is what is called as Benioff zone. इसको हम बोलते हैं Benioff zone. What is a Benioff zone? Benioff zone is a zone below the trench. ये trench है, उसके नीचे रहेगा. It is a zone below the trench where a large number of frequent earthquakes are observed, and that zone is called as Benioff zone. ये है हमारा ocean convergence. The best example of ocean convergence is along the western side of Pacific Ocean. So this is the Pacific plate. Pacific plate is moving in this direction. Okay, this is the Pacific plate. यहाँ पर जो deep blue color दिख रहा है ना, this is the plate margin. And this is where the Pacific plate is subducting. This is the Pacific plate boundary. Fine. And here the North American plate boundary is there. North American plate is moving here. This is the Eurasian plate. This is the Eurasian plate moving here. And this is Philippines plate, smaller plate. Philippine plate is also moving here. This is Pacific plate moving in this direction. Pacific plate is undergoing subduction in all the possible direction. हर जगह में Pacific plate ही subduct हो रहा है. This is the oceanic margin of North American plate. This is the oceanic margin of Eurasian plate. This is the oceanic margin of Philippines plate. This is the oceanic margin of Indo-Australian plate. This is the Pacific Ocean, which is completely oceanic plate only. Everywhere there is subduction. Okay, so here there is subduction, here there is subduction, here. This entire region is the region of trench. ये पूरा trench का ही region है. This is all trench only. This is where the Pacific plate is subducting. What are the trenches here? This is the very famous Mariana Trench. Mariana Trench is due to the subduction of Pacific plate below the Philippines plate. This is Tonga Trench. This is Tonga Trench. And this is the very famous Japan Trench. Okay, this is Japan. Japan के बगल में Japan Trench. And this is Kurile Trench. Okay, Kurile Trench, this is Aleutian Trench. Aleutian. Trenches का नाम है. Islands देखो. Next to Mariana Trench there is a continuous line of islands. ये पूरा islands है यहाँ पर. छोटे छोटे सा islands है ऐसे. छोटे छोटे सा islands है. They are all Mariana Islands. Here the subduction has been very intense over a long period of time. We have seen the formation of this island arc-shaped island. Can you see what is this? Japan? Japan itself is a island arc, a large island. Okay, थोड़ा सा zoom in करके दिखाता हूँ उनको. You can see? It has taken millions of years of formation. So this is Kurile Trench. This is Kurile Islands. Island arc. This is Aleutian Trench. This is Aleutian Islands. Alaska का extension है पूरा यहाँ तक आता है ऐसे. Continuous island arc. This is Java Trench. The Indo-Australian plate is subducting here. ये Indo-Australian plate है, ये Eurasian plate है. Eurasian plate का oceanic margin है. यहाँ पर बहुत ज़्यादा magma generate हुआ है. अभी भी intense activities चलता है. This large amount of magma gets generated and over a period of time, huge group of islands have been formed. This entire Indonesia का पूरा group है, it is the result of this subduction only. And this is what is archipelago. Indonesia. Philippines is another example here. Pacific plate इस side से subduct हो रहा है, Philippines plate इस side से subduct हो रहा है. Okay, double trench है. इस side से भी trench है, इस side से भी trench है. This is the Eurasian plate. And because of this, we have this Philippines islands. Can you see this large group of islands here? Philippines. This is also archipelago. When there is intense melting is happening, that produces intense magma generation, including our Andaman Nicobar. Can you see here? ये भी island arc है. Here there is a trench. यहाँ पर एक trench है near Caribbean. Okay, छोटा सा plate है Caribbean plate. Okay, so this plate is subducting here. ये trench है, इस side में magma generation होके यहाँ पर बन गया the Caribbean Islands. Caribbean Islands are also island arc. Okay, तो ये island arc देखो arc shape है. Fine. They're all the examples of ocean convergence. So very quickly ocean continent भी कर लेता है. Okay, दोनों में बहुत कम ही difference है. Quickly cover that. I'll dictate this in the next class. What happens when two parts of the plates are converging, and on one side there is a oceanic plate, another side there is a continental plate? Is it possible? Of course it is possible. Imagine this is one complete oceanic plate, ये पूरा अलग है, ये पूरा continental plate है, ये भी अलग है. दोनों साइड से कन्वर्ज करो, obviously one of them will undergo subduction. How is this possible when we did not see the option of ocean-continent divergence? Ocean-continent divergence is basically caused by the convection currents which are diverging here. Here you don't need that, you just need some push from behind. Okay, so that is possible here. So therefore ocean-continent convergence is also possible very easily. In this case, it is very clear, it is the oceanic plate only which undergoes subduction. Continent being much more lighter, it offers a greater resistance and greater buoyancy. It will definitely push it downwards completely. इसको पूरा अंदर दबा देगा. Same process happens, the subduction is happening here. This entire zone is what is called a subduction zone. Near to the subduction zone, you see the formation of trench. Here also there is trench. यहाँ पर भी एक trench बनेगा. The subducting plate undergoes partial melting here and then complete melting after a certain depth. Since it is getting pushed down, there is always earthquakes at all the different depths, shallow, intermediate, deep, everywhere there are earthquakes. There is also Benioff zone after certain depth. ठीक है, ये भी same ही है. The partial melting is generating magma. The magma is rising and accumulating on the other side of the plate, the other plate. There are two important differences here. First one, this is a continental plate margin, and this continental plate margin offers a higher resistance than compared with this oceanic plate margin. This was oceanic plate margin. It had little bit lower buoyancy than compared to the continental plate here. Because of higher buoyancy, higher resistance is offered, and because of higher resistance, the entire edge of the continental plate undergoes deformation. ज़्यादा ये resistance offer करने से क्या होता है, वो खुद deform हो जाएगा. What kind of deformation? There is entire compression. This entire plate is compressing with against this. This causes this entire part to undergo folding. The entire edge of the continent undergoes folding, resulting in the formation of fold mountains. Resulting in the formation of fold mountains. पूरा continent के edge में पूरा line ऐसे continuously आपको मिलेगा fold mountain. It is due to the greater resistance offered by the continental plate margin. The best example here is South American plate. So this is the Nazca plate. Okay, I told you about Nazca plate. Nazca plate is subducting below South American plate. This is South American plate. Okay, we have marked the South American plate. South American plate is moving in this direction because of this ridge. Atlantic ridge है ना, ये push करते जा रहे हैं. यहाँ पर एक ridge है between the Nazca and Pacific. Okay, that is pushing in this direction. Because of this, there is a convergence here. Nazca plate being oceanic plate, minor plate है, but oceanic plate है. It is undergoing subduction below the South American continental plate. The result is very clearly visible. Can you see here? There is a trench. This is the Peru-Chile trench. Okay, ये जो dark blue color में दिख रहा है ना, this is Peru-Chile trench. Next to the trench, due to the strong intense compression, you can see the formation of a fold mountain. The longest fold mountain on the surface of Earth, much longer than Himalayas, but not taller. Okay, extending all the way from here to here. पूरा जो continental edge है ऐसे fold हो गया. It's very high, tall mountains. This is what is called as Andes. पूरा continent के edge में है, जहाँ पर convergence चल रहा है ना, वहाँ पर ही. Same is the case with North America. The Pacific plate is subducting here. North American plate is moving in this direction. That has resulted in the formation of this huge fold mountains. This is what is Rocky Mountains. Okay, this is the first difference. You don't see such formation of mountains over there. वहाँ पर इतना intense compression तो नहीं होगा. The second important difference the magma which is generated due to the partial melting which accumulates this time on the continental crust. Earlier it was accumulating on the oceanic crust and that would have resulted in the eruption of magma on the oceanic floor. But this time it erupts on the continental crust. Okay, continent के ऊपर erupt होगा. But यहाँ पर तो already fold mountains बन गया. There is already fold mountains. Magma के लिए doesn't matter. It starts to rise and starts to come out on the fold mountains. It's not just fold mountains, it is a fold mountains filled with volcanoes, line of volcanoes all along its length. Unlike Himalayas. Himalayas are not the result of ocean-continent convergence. We don't have volcanoes here. Okay, it's a continent-continent convergence. It's a different process. Here, because of ocean-continent convergence, there is a subduction, there is a partial melting, magma generation, and this magma accumulates and comes out on the other side very easily. So therefore, there is line of volcanoes. All along the Andes, you will find continuous line of volcanoes. Okay, पूरा यहाँ पर, they are one of the most active volcanoes in the entire world. बहुत खतरनाक volcanoes है. On the continents. Why do we have volcanoes on the continents? It is because of ocean-continent convergence. Same is the case with Rockies. On the Rockies also we have many volcanoes. It is because of ocean-continent convergence. Difference तो यही है, बाकी सारा same है. ठीक है? Fine. So I'll not ask if you have any doubts. I know you will have many doubts. Okay, so I'll be able to resolve all that clearly if we complete this next part. Okay, so Monday we have got class anyway. Okay, कल नहीं है, मंडे है. मंडे प्लेट टेक्टोनिक्स खत्म होगा और बहुत है, पूरा डिटेल में कवर करते हैं. I'll dictate about both of this first, and then we'll move on to continent convergence. Okay, so any doubt, please ask me at the end of the plate tectonics. Okay, tabhi clear ho paega. I know you will have many doubts, it's okay. So better you can read from NCERT. NCERT पढ़ के आना काफ़ी है, बाकी और कोई डिटेल टेक्स्ट बुक अभी के लिए पढ़ने का ज़रूरी नहीं है. Okay, you don't have to read that. What I'm covering is sufficient. Okay, if you have confidence in me. ठीक है, चलो, we'll continue on Monday. Thank you.